Assalamualaikum Doktor. My name is Muhammad Afiq Aizudin. My matric number is D2018-1082-996 and my code is B23. In this video, I will teach and explain how to solve the question 1 from the assignment. Okay, the question is I need to evaluate limit at approach to 0 1 over sin x minus 1 over x square. Okay, first we need to substitute the value of x with the limit, where the limit is 0. Okay, we substitute and we will get limit at approach to 0 1 over sin 0 minus 1 over 0 square, and we will get infinity minus infinity, where it is in indeterminate form. So we need to use L'Hospital rule. There are 4 rules in L'Hospital rule, and for this question we need to use the differences. Okay, for the first step we need to get the single fraction. To get the single fraction we need same the denominator. Okay, to get same the denominator, 1 over sin x I multiply with x square, and 1 over x square I multiply with sin x. After that, I will get limit at approach to 0 x square minus sin x over x square sin x. After that, we need to substitute the value of x with 0, and I will get limit at approach to 0 0 square minus sin 0 over 0 square sin 0, and the answer is 0 over 0. It is still indeterminate form. So what we need to do next is we need to differentiate this equation. Okay, for the second step, we need to differentiate x square minus sin x over x square sin x. Differentiate x square, we will get 2x, and differentiate sin x, we will get cos x. For the denominator, we need to use product rule, where the product rule formula is u prime v plus v prime u. So this is the step how to use the product rule. So after we differentiate this equation, we will get limit at approach to 0 2x minus cos x over 2x sin x plus x square cos x. So this is the new equation after we differentiate. After differentiate, we need to substitute the x value with the limit, where the limit is 0. So we substitute, we will get limit at approach to 0 2 times 0 minus cos 0 over 2 times 0 sin 0 plus 0 square cos 0, and we will get negative 1 over 0, where this is equal to negative infinity. So the final answer for the question is negative infinity. That's all. Thank you.
Hi, this video is for SMN 3023, L'Hospital rule and improper integral. Question number 2. For solution, we will use limit. We will write limit t approach to infinity to the function of velocity of time equal to the limit t approach to infinity mg over alpha times with in the bracket of 1 minus exponent raised to the power of negative k over m times by t. Take out the mg over alpha term. This will leave us with limit t approaching to infinity in a bracket of 1 minus exponent raised to the power of negative k over m times by t. After that, change the exponent raised to the power of negative k over m times by t into 1 over exponent raised to the power of k over m times by t. This will give us mg over alpha limit t approaching to infinity in a bracket of 1 minus 1 over exponent raised to the power k over m times by t. As we can see here, the t term in the bracket is actually our indeterminate form of differences. Since it is indeterminate form of differences, therefore we need to get a single form by making them into a common denominator. So the common denominator for this term in the bracket will be exponent raised to the power k over m times by t, and the new numerator will be exponent raised to the power of k over m times by t minus 1. Next, substitute the infinity value into the t terms. This will give us infinity over infinity as an answer. Since we get infinity over infinity, we need to apply L'Hopital rule. In this L'Hopital rule, we need to find the derivative of exponent raised to the power k over m times by t minus 1 divided with derivative of exponent raised to the power k over m times by t. So after we do the differentiation process, we will get limit t approach to infinity, k multiplied with exponent raised to the power of k over m times by t divided by m as numerator, and for the denominator we will get k multiplied with exponent raised to the power of k over m times by t divided by m. So this numerator and denominator can be cancelled out. Therefore, the final answer we will get 1. So for the final step, we just need to plug in value 1 to the term that we have already derived before. So the final answer will be mass times with gravitational constant over alpha, which is a constant that have a value more than 0. And that's all from me. Thank you.
So today I will be answering question number 3. Give that function x equal to ln x over square root x. Find integrate function. Hence, evaluate integrate from 0 to 1 functions. Step 1 is integrate the functions by using integration by parts. Let u and v first. U equal to ln x, so we differentiate it, become du equal to 1 over x dx. dv equal to square root of x, then we got v equal to 2 square root of x, and put into formula given uv minus integrate v du. Then we get then it become like 2 square root of x ln x minus integral 2 square root of x times 1 over x dx. After that, we pull out the 2 from that equations. Then we can cancel square root of x and x, and it will become 2 square root of x ln x minus 2 integral 1 over square root of x dx. Then we change the square root of x to x to the power of 1 over 2. Then we do the integrate, and we got the answer is 2 square root of x, and we times 2 in front of that. to evaluate the integral from 0 to 1 ln x square root over square root of x. Find the undefined value of x. Denominator is square root of x, so I substitute 0 into the denominator square root of x, so then I get the 0. So I mean that undefined value of x is 0. I add the limit t approaches 0 to the functions, and I change the integral 0 to t because limit t approaches to 0. Then I substitute the value into the functions, and I got the answer is positive infinite. Since this limit does not exist, this function is divergent.
Question 4. Determine how large the number of rows has to be so that integration from rows to positive infinity of 1 over x squared plus 1 dx less than 1 over 1000. The equation is called improper integral. There are two types of improper integral, type 1 and type 2. Type 1 is infinite limit of integration, where one or both of the boundaries is at infinity. Type 2 discontinuous integral, which is integral with vertical asymptote. For this question, it involves improper integral type 1. As you can see, the upper limit is positive infinity. To solve the problem, step 1, replace infinity with some variable, which is in this case I will use b, so let b equals to positive infinity, and then express it as a limit, so it will be limit b approach to positive infinity of the integral from rows to b of 1 over x squared plus 1 dx less than 1 over 1000. Step 2. Calculate the antiderivative of 1 over x squared plus 1 dx using inverse trigonometry substitution. The first step to evaluate integration of 1 over x squared plus 1 dx is determine the value of a and u. In this question, the value of u is x, while the value of a is 1. As u equals to x, the derivative of x equals to 1. Based on the formula, integration of du over a squared plus u squared equals to 1 over a r tangent u over a plus c. As the value of a equals to 1, so we get r tangent u. Replace u with x, so we will get tangent r tangent x. So the equation will be limits b approach to positive infinity r tangent x from rows to b less than 1 over 1000. The next step is we need to replace x with b, so that's going to be r tangent b minus replace x with row, so it will be r tangent row less than 1 over 1000. As b approach to infinity, replace b with infinity, so the equation will be as given. The next step is we need to summarize the equation of r tangent infinity minus r tangent row less than 1 over 1000. R tangent infinity equals to pi over 2. So pi over 2 minus r tangent row less than 1 over 1000. The next step is we need to group together the value on the right hand side, because we want to calculate the value of row in the last step. The last step is we can calculate the value of row, so the value of row is more than 1000.